So angles of elevation and depression. So if you can imagine someone is on the ground and they're actually looking up. So this is horizontal. This is your ground. Their line of sight is looking up at an object. So the angle here formed is called the angle of elevation. Now, if someone was on the top of a cliff and maybe there's a boat in the water and they're looking down at this boat, the angle here is called the angle of depression. Okay, so this here is the angle of depression. This is that formed, and the angle of elevation is from the ground looking up. So let's look at some questions. So from the top of a vertical cliff 100 meters high, Khalid sees a boat out at sea. The angle of depression from Khalid to the boat is 42 degrees. How far from the base of the cliff is the boat? So we need to find this distance here. So what we can do, draw a triangle. Now remember that this is alternate angles, so it's going to be the same distance. So this is what we're trying to find. So this is 42 degrees and the height is 100 meters. So the first thing I'm going to do is label my triangle. So this is height, this is adjacent, and this is opposite. I'm going to eliminate the angles I don't need. So I don't need height. So with SOHCAHTOA, I don't need anything with a H. So I'm going to use tangent. So the tan of theta is opposite over adjacent. So tan 42 is 100 divided by x. So rearranging the formula, we would have x is equal to 100 divided by tan 42. And if I put that into the calculator, I'll have 111 and it's meters. So the cliff or the boat is 111 meters away from the cliff. So Mayed sees an aircraft in the sky. The aircraft is at a horizontal distance of 25 kilometers from Mayed. The angle of elevation is 22 degrees. How high is the aircraft? So we need to work out how high this aircraft is. So let's draw a triangle. So this is 22 degrees. This is 25 kilometers. And this is the angle we're trying to find. So let's label it hypotenuse, opposite, and adjacent. So write in SOHCAHTOA. We don't need height, so anything with H we can eliminate. We're going to use the tan. So tan 22 degrees, opposite is x, adjacent is 25, and we're going to rearrange the formula. So we have x is equal to 25 multiplied by tan 22. And if you put that into the calculator, we'll have 25 multiplied by tan 22, and x is 10.1. So that's 10.1 kilometers. So the aircraft is 10 kilometers high. Okay, roller coaster. The hill of the roller coaster has an angle of depression of 60 degrees. Its vertical drop is 60 meters. Estimate the length of the hill. So here's a triangle. This is 60 degrees. This is our angle. We know the height is 60 meters. We need to find the length of the hill. So let's label our sides. So we have, this is the height, this is opposite, and this is adjacent. So I'm going to write SOHCAHTOA. So we're going to eliminate the sides we don't need. So we don't need adjacent. So anything with A, so I'm going to use sine. So sine of theta is going to be equal to opposite over hypotenuse. So if I substitute in the values, that's 60, sine of 60 is equal to 60 over x, and I don't know the value. So I'm going to rearrange, and this is 60 divided by sine 60. Okay, so if you put that into our calculator, 60 divided by sine 60, x is equal to 69.28. Well, we're going to round it, so we're going to say x is approximately 70 meters. Right, guided practice, moving. A ramp for unloading a moving truck has an angle of elevation of 32 degrees. If the top of the ramp is 1.2 meters above the ground, estimate the length of the ramp. So this is our ground. So this is horizontal. And then we have a ramp up to our truck with the angle of 32 degrees. So this goes up to our truck. So if we what do we need? 1.2. So we know it's 1.2 meters above the ground. Estimate the length of the ramp. So we need to find x. So let's draw this as a triangle. 32 degrees, 1.2, and this is x. Label our sides. Hypotenuse, opposite, and adjacent. We can see straight away we don't need adjacent. Opposite over hypotenuse is sine. So we have the sine of 32 is equal to 1.2 divided by x. Rearrange, x is equal to 1.2 divided by sine 32. Put that into the calculator. 1.2 divided by sine 32. And we have an answer 2.26. So we can say that is approximately 2.3 meters long. Okay, 6b, ladders. A 14-meter ladder is placed against a house at an angle of elevation of 72 degrees. How high above the ground is the top of the ladder? So let's draw this. So this is the house, and we have a ladder, and this is the ground. So the angle of elevation is 72 degrees, and the ladder is actually 14 meters long. How high above the ground? So we need to find this length, x. So draw a triangle. This is our triangle, 72. This is 14 meters. And we're going to label our sides. So this is the height, this is the adjacent, and this is the opposite. I don't need adjacent, so I'm going to use the sine formula. So sine of 72 is x divided by 14. So rearranging, x is equal to 14 multiplied by sine 72. And I'm going to put that in the calculator, times sine 72. And I've got a length of 13.31. We're in meters. So we'll say x is approximately 13.3 meters.